we're covering a chapter in an hour. So, all right, so the first part we're going to look at is the algebraic expressions, mathematical models, and real numbers. Hopefully everybody remembers the order of operations. So the please excuse my dear Aunt Sally. The parts that are really important to remember for this is that you need to make sure that you're doing multiplication and division from left to right as they occur, and addition and subtraction from left to right as they occur. Those are probably the two absolute biggest things. So multiplication and division are from left to right, addition and subtraction are left to right, and the rest of it's the same. So all your parentheses, all your exponents, and then multiplication, and then addition, subtraction, and it's left to right. So you do it as you come to it from left to right for those. That's probably, like I said, that's the biggest mistake I think I see people do. We will, let's work out number 2 first. So it's an algebraic expression, and the directions would probably say simplify. So we want to go through and work this guy out. You've got to start to clear your parentheses, but you're starting on the very inside of it, so in the middle. So we're going to distribute this 6 first. So when we do that, then this portion becomes 6x squared minus 12, and then the plus 5 still there. That's all in brackets. And there's still a negative out in front. All right, I'll write it bigger over here. The next thing we need to do is get rid of the brackets. Well, we can combine like terms in the brackets. How about we'll do that first to make it shorter? Well, sort of shorter. So we have 18x squared plus 4 minus, and then we're going to have the 6x squared, and then the minus 12 plus 5 is going to give you what? Yeah, minus 7. And now we can clear. I'm going to just distribute the negative through. So we end up with the 18x squared plus 4. The negative 6x, everybody's pretty good about that one. So negative 6x squared. It's this next one. That negative also has to go to that negative 7. We're just going to make it a, exactly, going to make it a plus 7. Combine like terms. So the negative 18x squared and negative 6x squared, they're going to give you a 12x squared. And they're like terms because they have the same variable with the same exponent attached. And then plus 11, because the 4 and the 7 can go together. And that's going to be all you can do to that. So you're just simplifying it, meaning you're just making it look nicer. Because quite frankly, 12x squared plus 11 is a lot nicer than the first thing, right? Than the 18x squared and so on. Yeah. All right, do you guys feel like you pretty much remember order of operations? Yeah, good. Number 3, the only trick there, which isn't really a trick, there's some absolute value signs. Absolute value bars, treat those like parentheses, meaning that you're doing the stuff in there before you're doing anything else. And also the numerator of a fraction or the denominator, so the top of a fraction or the bottom of a fraction, sort of has invisible parentheses around it. So if we wanted to, we could add these, and it's the same, meaning that you're going to need to put the whole numerator together and put the whole denominator together before you divide. So you would go ahead and work out the absolute value. So the 2 squared plus 3 squared, inside that, so all of that's in the absolute value bars, so you're going to do that portion first. So the 2 squared is going to give you the 4, plus 3 squared is going to give you 9. Put those together and we get 13. Now in this case, the absolute value doesn't really do a whole lot because we're just going from absolute value of 13, well, it's 13, it's a positive 13. Then you would make it, so you would work out what's in the absolute value bars, and then make it positive. Right, so if they had been tricky and put 2 squared minus 3 squared in there, then it would have been 4 minus 9 or negative 5. Well, we would have changed that to a positive 5 in a parenthesis, basically. Yeah. Yes? So once you solve for the absolute value, Correct. Correct. Yeah. So you can still, to do the absolute value bars, or you're just making it positive. You're doing what's inside, making it positive. But then to safely leave it there, just put parentheses around it. Yeah. Oh, and everybody hates word versions of doing anything. We'll just do number 5. So 6 times the product of -5 and a number. What's product mean? Yeah, multiply. So 6 times, that's actually quite nice, right? That means 6 times. The product of -5 and a number. What's the product of -5 and a number? Sorry, what'd you guys say? Yeah, -5 times x or -5x. So it's wanting us to do 6 times. Whoops, that's a fun mark. There we go. Times -5x. The reason I'm putting parentheses around there is if it had said negative, or if it had said 6 times the sum of. So if it had said the sum of, you're going to have to do parentheses around that because it wants you to do -6 times the entire sum. So actually, let's just. If we change that to sum, then we're going to have the -6 times, and then we have to do the sum of -5 and a number. Yeah, so -5 plus x, and close your parentheses. So you've got to make sure that's what the parentheses are for. You do the sum first, then multiply by the -6. So that's probably the only way to make that real tricky. So mathematical modeling is basically just word problems. It's where you're taking a situation and modeling it with a formula or a function. So football was kicked vertically upward from a height of 4 feet with an initial speed of 60 feet per second. The formula, h equals 4 plus 60t minus 16t squared, describes the ball's height above the ground, h, in feet. So it's letting you know that h is how high it is, and that's going to be in feet. And t seconds after it was kicked. So t is going to be your time in seconds. So if it says, what's the ball's height 2 seconds after it was kicked, how do we find that? Yeah, we plug the 2 in, right? Because it says 2 seconds after, and that's our time. Yes, we're going to plug it into the t. So our height is going to equal 4 plus 60 times 2 minus 16 times 2 squared. Let's see if I can do this without a calculator. And somebody feel free to do it with a calculator behind me. So let's see, this will be 16 times, no, 2, 4. So just 4 times 16? Same as, so 64? All right, so 60. 60 what in reference to this problem? So it's going to be 60 feet, right? Because we just solved for h. And if I had been really proper, I would have kept pulling that h down. And then it would have been a less tricky question. Is that okay? All right. This one you guys may or may not remember or be familiar with. So we're talking about sets and intersection and union. So intersection is what they share. So whenever you guys are at an intersection driving, it's that area of road where they overlap, right? Okay. And union means everything. So if we have the union of 2 people and all their stuff, that means that we're not looking at it as one person's stuff and another person's stuff. We're looking at it as cumulative, all their stuff together. So if they share something to begin with, that's still in there. If they own something individually, that's in there now. So whenever we're applying that to sets, and the upside down U is intersection, and the right side up one is union. So the one that looks like a U is union. The one that does not look like a U is intersection. So the intersection for 1, so we're looking at the sets, and that set notation, that's a little brace. So it's this guy. So a brace just means that it's a set, and anything you put inside the braces is going to be the list of elements in your set. So we have the first set with 0, 1, 3, 5. The second set with -5, -3, -1. What do they share? Nothing. So it's the empty set. And you can denote the empty set just by a set of braces. Or, yep, this guy. That's also the symbol for empty set or null set. If you were to do the braces and put a 0 in there, thinking you were telling me there were no elements, you just put the element 0 in there, right? So you can do the empty braces or you can do the null set sign. All right, what about 2? So we have the set A, B, C, D, and we have the empty set. What do they have in common? Nothing, which is sort of they have nothing. What's the answer? Yeah, the null set, right? Empty set. Are those okay? All right, union's easier. Let's do number 3. So the union of 1, 2, 3, 4 and the set 2, 4, 5. Yeah. And you guys already did what I was thinking I might trick you, or you skipped what I thought I might trick you on. You do not repeat the elements. So once it's in there one time, it counts. We know it's in there. All right, what about set 5? We have the set number 5. We have the set A, E, I, O, U, union, the empty set. What are we going to get? Yeah, just the A, E, I, O, U, right? Is that okay? All right, good. The super quick version of inequalities. So hopefully you guys remember the less than, or equal to. So less than, or equal to, greater than, or equal to. If it has the extra line, it has the or equal to. Less than makes kind of a very bent over, bendy L, right? So L, less than. That's how I remember it. Remember it however you want to. And remember that the symbols always want to be open towards the bigger number or the bigger amount. So they're like little Pac-Men trying to eat the bigger one. Okay. So we're going to figure out if 1 through 4 is true or false. And, well, we'll get there. Let's see if you missed number 1 first. So -13 is less than or equal to -2. Is that true or false? Mm-hmm. So less than or equal. So one or the other works. So the -13 less than or equal to -2. So this is true. But I'm going to do you a quick number line right quick. So well, here, let's do 0, -2, and then -13 somewhere down here, right? -13 is to the left of -2, which means it's going to be less than. With negatives, it just gets confusing. So you guys are great at drawing number lines in general. So if you're wondering, like, don't miss an easy question just because you didn't want to take the extra 15 seconds to do a number line. That's the reason positive numbers are bigger than negative numbers. Positive numbers are to the right of all the negative numbers. All right, what about 4? Or sorry, number 2. 4 is greater than or equal to -7. Yeah, that's true. All right, what about number 3? -pi is greater than or equal to -pi. That's true because they're equal, right? The or equal. Okay, you guys didn't freak out about being pi. That's good. 0 is greater than or equal to -6. Yeah. All right, now here's the absolute value stuff, even though we already kind of did a little bit of it. So absolute value just means whatever's inside of there is going to be positive whenever you take it out. So if it was negative to begin with, it becomes positive whenever you remove the absolute value bars. Absolute value is very useful for distance. So if I ask you how far it is from here to your house, if you tell me 5 miles, and then I say, well, how far is it from your house to here? You're still going to tell me 5 miles. So distance, measurement, things like that, it's always going to be positive. So it's the absolute value of A minus B or B minus A. It doesn't matter. Because once you take the absolute value, you're going to get the positive answer. Yeah, I won't jump into that too hard. Okay, So some of the things you need to know about absolute value. For all real numbers, a and b, that absolute value is going to be greater than or equal to 0. Well, that makes sense. That also lets you know you can take the absolute value of 0, and it's just 0. And then absolute value of anything else is going to be bigger than 0. The absolute value of a times b is the same as the absolute value of a times the absolute value of b, which hopefully also makes sense. So if you have 2 times a negative 3, you get a negative 6, and then take the absolute value. If you do the absolute value of 2 times the absolute value of negative 3, you end up with a 2 times 3, which still gives you a 6. Absolute value of a plus b is less than or equal to the absolute value of a plus the absolute value of b. We won't go into it too hard, but essentially the absolute value of a plus b, if one of those is going to be a negative and one's a positive, it's going to give you a smaller answer than absolute value of a plus absolute value of b. Absolute value of negative a is the same as the absolute value of a. So that's saying that the absolute value of 6 is the same as the absolute value of negative 6. Absolute value of a over b is the same as absolute value of a over absolute value of b, assuming you're not dividing by 0. And a will be less than or equal to the absolute value of a. So just kind of some rules. A lot of them you guys can probably figure back out if you just think sort of hard for 20 seconds. All right, so let's see. We'll go ahead and do number 1. So square root of 2 minus 5. Which one of those two numbers is bigger? Yeah, that 5 is going to be bigger, right? Okay. So square root of 2 minus 5 gives you a negative. Yeah? We're getting there. I'm just talking about the inside part. So the square root of 2 minus 5 gives us a negative. Okay. Well, using this guy up here, the absolute value of a minus b is the same as absolute value of b minus a. Can't we rewrite this as the absolute value of 5 minus square root of 2? And then it's going to be positive, right? Well, we're not going to change it to plus because 5 minus square root of 2 is already positive. And then we would take the absolute value of it, which would leave it positive. So at this point, we can comfortably remove the absolute value bars. So we can say, oh, it's the same thing as just doing 5 minus square root of 2. So the not square root of 2 example, if we had something like 3 minus 5, the absolute value of that, you guys know that's negative 2. You take the positive, it's going to be 2. Well, we can rewrite that as 5 minus 3, which is 2, and then drop the absolute value bars, and then it's just the same as 5 minus 3. Do you guys? For number 2, so negative 3 over absolute value of negative 3 is going to be what? Yeah, negative 3 over 3. All right, and then this one's double absolute value bars. I don't know if you guys caught that or not. So just like we did with our grouping symbols, like with our parentheses and our brackets, you start on the most inside as you possibly can. So the first thing I want to do is leave the big ones. Absolute value of negative 3 is going to give us what? Yep. Keep the minus. And the absolute value of negative 7? Yep. And then do it again. Yeah, so the 3 minus 7 gives us a negative 4. When we take the absolute value of that, we're going to get a positive 4. Is that okay? Okay. Yes, ma'am.
I have a question about number 2.
Mm-hmm.
Negative 3 over 3 is not negative 1.
Oh, yeah, we should go ahead and reduce that. Thank you. Good call.
Wait, but I thought we can't get negative again.
No, we can get it. We can, because the whole thing wasn't an absolute value. Wasn't in absolute value bars. Right. Right. Yes, good comment though, because actually a lot of people will do that. That's a pretty common mistake. We're not going to do a whole lot on this page. It's just there for information for whenever I send you guys notes. Negative 1 is better answer. Yes. I'm just trying to be in a hurry. Yes, negative 1. Okay, so this is useful as far as sets, and also just knowing if it says pick a natural number, like what your options are. So natural numbers are also called counting numbers. And so whenever you were a kid and you played hide and go seek, what did you start with? Started with 1. You went up by whole numbers. So your natural numbers are 1, 2, 3, 4, 5, and so on. Your whole numbers, they just added a 0. Your integers, they just added the negative whole numbers. Rational numbers, anything that can be written as a fraction. Whole numbers count because 3 is the same as 3 over 1. So that still counts. Rational numbers are going to also be any ending decimal. So if the decimal ends, then you just count however many places it went out, and it's a 1 and that many zeros on the bottom. Or if the decimal repeats, which we're not going to get into that one as far as converting it back to a fraction, but your calculator is great at it. But if it's a repeating decimal, it will also be a rational number. The irrational numbers, so these are guys that are, if you gave a decimal equivalent, the decimal never ends and it never repeats. So it just goes forever. So square root of 2 is an example. Pi is a favorite. So we normally use 3.14 to approximate pi, but it truly is an approximation. Pi goes forever. Yeah, we'll just stop there. And then as far as how everything relates, real numbers are all of those things that we just mentioned. And then so the natural numbers are within whole numbers because the whole numbers are natural plus 0. Then integers have whole numbers inside of them because the integers are just all the whole numbers plus the negatives. And then rational numbers are all the integers, so all the positives and negatives, positive and negative whole numbers, plus all those numbers in between that can be written as a decimal. And then the irrational numbers are outside of the rational numbers, but they're still all real numbers because they don't have an imaginary part. They're still all real numbers. So everything that we're dealing with in the immediate will be real, and it will either be rational or irrational, but you can't be both rational and irrational. That's kind of true for people, right? You're either rational or you're irrational. Yeah? Okay. Here's all the properties that you guys have probably forgotten the names of, but you know how to do anyway, which the know how to do anyway is the important part. So commutative, that you can change the order you add things in. That with like addition, it doesn't matter what you add first. Same with multiplication, doesn't matter what you multiply first. That's the distributive property. That's going to be your friend to get all the way through this class, I promise. If you add 0, it changes nothing. If you multiply by 1, it changes nothing. If you add the opposite, you get 0. So 6 plus negative 6 is 0. And for the inverse property for multiplication, if you multiply by 1 over whatever the number was, you're going to get 1. So if you have 6 times 1 over 6, so 6 times a sixth, you're going to get 1. I'm not sure why 6 is my favorite number today. Let's see, what else? Oh, I'm going to mention this. So subtraction is the same as adding the opposite. So it depends how you learned how to subtract as to if you're happy with that explanation. Some people were taught to subtract that if you have 3 plus 2 minus 7, that you should rewrite that as 3 plus 2 plus negative 7. And you know that if you have the same sign, then you add them together and you keep the sign. If you have opposite signs, then you find the difference and you keep the sign larger number. Whichever way makes you happy, go with it. All right, so section P.2, exponents and scientific notation. I've gone ahead and put the exponent rules here for you guys. But essentially, for these to work, your base needs to be the same whenever you're talking about. So it says b to the m times b to the n equals b to the m n. It's kind of hard to read on there. So if you have something like 3 to the 5th times 3 Okay, let's see what I can make that into. To the 4th. That'll be 3 to the 9th. So you're just adding them up. If you have them over top of each other, you would subtract. So if you have, let me make sure I'm not going to do my examples that are down here. Oh, good. I gave us much harder examples. It's a touch screen, by the way. So if I hit it, anyway, it's been fun. So we have something like 3 to the 6th over 3. Well, I already made it part of a 4. So we're going with 3 to the 4th. That's a horrible 3 to the 4th. There, we'll make the 3 bigger. There. We're just subtracting. So the bigger number is on top. So I'm going to start with the 6 and do 6 minus 4. So 3 to the 6 minus, wow. That's really extra horrible. So there, 3 squared. There, at least it's legible at the end. Correct. Yeah. I'm going to flip 3 to the 6 over 3 to the 4th over. So I'm going to change it to 3 to the 4th over 3 to the 6th. I can still use the same idea of subtracting exponents. My bigger number's on bottom. So I'm thinking 3 to the 6 minus 4. Now here's my trick question for you. What's on top? 1. Because the 3's on top went completely away. They fully canceled. Anytime something completely goes away with multiplication or division, it leaves a 1. If something goes completely away with addition or subtraction, it leaves a 0. Yes. Yeah, it's because the bigger number's on bottom, so 3 to the 6 is on bottom.
So you go wherever the big number is.
If you want to keep a positive exponent, you go over the bigger number is. Which brings me, we're going to go right into negative exponents from this. So if you want to change the sign of an exponent, you just take the base and the exponent and flop it to the other side of a fraction bar. So if I had worked this out and I got 1 over 3 squared and it says no, so don't write it in fraction form. Then I can pop this 3 to the 2 to the top and just change the sign of the exponent. So 3 to the negative 2 is the same as 1 over 3 squared. And you can do it either way. If we the first one in purple, the 3 squared, if we wanted to put it on the bottom for whatever reason, 1 over 3 to the negative 2. So typically you're going to change things to make positive exponents, but you can change the sign. It's just a matter of changing it by taking the base and exponent and putting it on the other side of the fraction bar. And then also when you multiply your exponents, so if you have something like 3 to the 5th cubed. So a power to a power. Whenever I was in school, it was called nesting. I don't think it's been called that for a long time. But the power to a power. So this is whenever you are going to multiply these, and you're going to get 3 to the 15. Because what this is saying is 3 to the 5th times 3 to the 5th times 3 to the 5th. So that's what 3 to the 5th cubed actually means. If those start to confuse you, like write them out. It's better to take an extra 45 seconds and get it right. Let's see. Oh, and any number besides 0 to the 0 power is going to give you 1. All right, so for number 1 here, we have 5x cubed over y to the negative 2 power. So we're going to kind of show one of these in action. This negative 2, what happens to it? Yeah, we're distributing it in there, right. So we have, so we have 5, and then do I have a power here or not? Yeah. Yes. That's the power people miss. And then x to the what? Yep, over y to the negative 2. And then if it said, hey, I only want positive powers, then how would we rewrite this? Yeah, just flip it and make everything positive, right? So I'm going to take this guy up top first. So y to negative 2. Take, And then on bottom, we're going to have, yep, perfect. Is that okay? Yes, ma'am.
So, it would have been wrong if they kept 500 on top.
If you kept it positive on top, yes. Yes. If you need to change the sign of an exponent, you just take the base and the exponent and put it on the other side of the fraction bar. Well, you can move it either way. So if we had all positive exponents and for whatever reason you wanted negative ones, we can still do the same thing. We can still move the base and the exponent to the other side and make it negative if it was positive to begin with.
Will they ask you whether they want a negative or positive?
They'll tell you, yes. They'll say stuff like use only positive exponents, or that's probably what they'll say. Or they'll have a little bit of leniency with how you put the answer in if they don't give you directions like that. My directions don't, but there's a good chance that your directions will. Yeah. Because I asked us to make positive exponents. So to get rid of the negatives, we have to take the base and the exponent and put it on the other side of the fraction bar. How about we'll work through number 2? It has a tricky spot in there, even beyond the first one. So 2, it's negative 15, a to the 4th, b squared, all cubed, over 5, a to the 10th, b to the negative 3. There's a couple things we can do here. So the first one, we just had an x on top and a y on bottom, so we didn't have any common variables on top and bottom. But because with number 2, we do have common variables on top and bottom, we can combine them, right? Or we can essentially reduce it or simplify it. So if we take this, I'm going to rewrite it real quick. Right, so if I want to, how about if I reduce the numbers first? What do I get? So the 5 goes away, 5 goes into 5 once, 5 goes into negative 15, negative 3 times. All right, and then for the a's, I can either do a to the negative 6 on top or a to the 6 on bottom, right? Either one's the same. So if I do 10 minus 4, that's going to give me a to the 6 on bottom. So I'm going to get rid of that guy and make this a to the 6. Now this one's a little tricky. So I got b squared over b to the negative 3. So it's b to the 5th. I heard the answer in the back. So because if you do 2 minus negative 3, that's the same as 2 plus 3, which will give you the 5. The other thing you could have done is rewritten this b to the negative 3 on top as b cubed. So then you have b squared times b cubed, or b to the 2nd power times b to the 3rd power, and then you're adding. So this is going to turn into b to the 5th on top. Yes? Okay. All right, the b's. How about we will talk about the b's over here. So we had b squared over b to the negative 3. One of the things we could have done is rewritten this b to the negative 3 on top. So we could have rewritten this as b squared times b cubed, because we take the base and its exponent, so the b to the negative 3 on the bottom, and then we move it on top, it makes the power positive, or it's going to change the sign of the power. So we could do it that way, and then we have b squared times b cubed is b to the 5th. The other way to think about it, so we have the b squared over b cubed, or negative 3, sorry. And we have the bigger number up here, that's the same as b to the 2 minus a negative 3. Because we're doing the top power minus the bottom power in that instance, those two negatives turn into a positive. So we're going to end up with actually plus a positive, which will still give us that b to the 5th on top. All right. Okay, good. Yes, ma'am. Correct. Yes. All right, so I'm going to rewrite this little mess here because it's not too bad anymore. We ended up with a negative 3 b to the 5th over a to the 6th all cubed. So we're getting there, right? It's a lot better. It's a lot nicer looking. Okay, so we know to distribute that 3 because of what we already figured out last time. I'm curious how this is going to go. So the reason this one's tricky is that negative 3. If we take that negative 3 and cube it, is it positive or negative? It's going to still be negative. I'm going to go ahead and work it out. So, and I'm going to write it this way to make it really clear that we're taking the negative 3 and cubing it. And then b to the what power? 15, right? Once you go ahead and distribute for me, over a to the, yeah. And the reason I'm writing this out this way is because negative 3 is really the same as negative 1 times 3. But anyway, I'm keeping the parentheses around the negative 3, even though I would have gotten the same answer without the parentheses. But if it had been an even exponent, if it had been squared without the parentheses, I would have gotten the wrong answer. So just kind of keep that in mind. Which actually, we're going to skip that nice fun guy. I know you're disappointed. So with negative 2 to the 4th versus negative 2 all to the 4th. So negative numbers are like a negative 1 times a positive version of it. That 4, that 4th power, is only going to the 2 in this top one. So we're going to keep the negative. So let's see, 2, 4, 8, 16. So negative 16. On bottom, it's saying negative 2 times negative 2 times negative 2 times negative 2. You end up with 4 negatives, which gives you a positive. So that's going to give you a positive 16. That's part of the reason I was making a big deal about the parentheses. Because even though it was an odd number, so it didn't matter, but if it had been an even exponent, it would have. Is that okay? Because the top one is doing negative 2 times negative 2 times negative 2 times negative 2. The top is just doing negative and then 2 times 2 times 2 times 2. But that negative is sort of attached, but not really attached. Correct, just for the first one. Because the parentheses are saying rewrite this whole thing 4 times. Oh, yes, yes. This will kill you in the calculator. Odd exponents is not as bad, obviously, but even exponents, if you don't know if you're supposed to have parentheses or not, it'll absolutely, it'll get you. So, scientific notation, big things to remember is it's a number times 10 to a power. That number has to be 1 or bigger, but less than 10. So basically you have to have a whole number and then a decimal. So an integer, decimal, the rest of your number times 10 to a power. So for 64,000, the decimal for the number part is going to go where? Yeah, so I have 6.4 times 10 to the 4th power. And truthfully, the way I think about these is if I put the decimal here, to get it back where it was supposed to go, I've got to make the number bigger, so I know it'll be a positive, and I got to bump it over 4 places, right? 1, 2, 3, 4. So it's going to be a positive 4. For number 2, the decimal is going to go between what numbers? Yeah. So we're going to have 5.04. I'm not going to forget my negative, even though I just about tried to. So for me, again, the way I do them is I think, well, that's where my decimal, that's where I'm going to put it for scientific notation to get back to my original. Now I'm really wishing this was bigger. Let's see, 1, 2, 3, 7, 8, 9. Do you guys also get 9? Okay. Times 10 to the 9, but it's not the 9. It's the negative 9 because we went backwards because we made the number smaller. Yeah, I'll go ahead and say it. So 10 to the negative 9. So side note. And I'm going to do actually a smaller number. I'm going to do 10 to the negative 3. Because we just talked about exponents. If I want to write that as a positive exponent, what is it?
It's 1 over 10 to the third power.
Perfect. Which is the same as 1 over.
10 times 10 times 10.
So I'm going to go ahead and work it out and go 1,000. So what it's saying is we're, so if I had something like 2 times 10 to the negative 3, then this would be the same as 2 times, make that a times sign, 1 over 1,000, or 2 thousandths, or, right? All the same? Okay. Yes, ma'am. Yes, because it was a negative to begin with. The only way to keep it negative is to have the negative in front of the number. Yeah. Because a negative exponent doesn't do you any good, right? Negative exponent just means you're making it tiny. We're going to skip these for time's sake. Your calculator's great at them. All right, section 3, radicals. The radical sign is the little crazy check mark thing. Your radicand is the thing underneath. The whole thing's called a radical expression. The one we talk about most of the time is the square root. And so if you see a radical sign with no number in the little crook of the crazy check mark sign, then that just means take the square root of it. The square root is whatever you square to get the inside number, that's your answer. So what do you square to get 36? Right. And this one, 144 plus, thanks. Thank you. Because you square 13 to get the 169. What we're writing is the principal square root. The principal square root is the one we mentally default to, which is the positive. Technically, if we were to square negative 6, we would get a positive 36, right? Unless it's being specific, or later on whenever we're solving for stuff, and you guys will know when, you're going to go ahead and assume they want the positive answer. They want the principal square root. All right, so if you take the square root of a variable squared, whenever you pull it out, you have to put the absolute value. So it's no different because we're giving the principal square root. Because it's no different than what we just talked about, that the square root of 6 squared is going to give us 6. The square root of negative 6 squared is going to give us 6. Those are both going to spit a 6 out. But if those had been an x, so the square root of x squared or the square root of the negative x in parentheses squared, it's still going to give us a positive x. So we've got to make sure we're taking the absolute value of it so that we're given the positive answer. So for number 1, the square root of 45. 45 is 9 times 5, right? So 9's a perfect square. Comes out as, right? So it's going to come out as 3, and that 5, there's nothing we can do with it. It stays inside. What about the x squared? Comes out as absolute value of x. So 3 times absolute value of x times the square root of 5. Yeah, so 3x root 5. But the x has the absolute value on it. And it will ask you for, I'm pretty sure it'll ask you for the absolute value in homework. So if you're pulling a variable out, pretty much put absolute values around it. Unless I guess it says not to, unless it says to assume it's positive. Some of the times the directions in the original problem will say assume all variables are positive. If it says that, you don't need absolute value bars. 125, x squared. 125 is the same as 25 times 5. So the 25 comes out as a, good Gonna, yeah, leave the radical 5, leave the 5 under the radical. Exactly. Is that okay? And I'm not sure what order they want it in. I don't think they're going to want it that way. I'm pretty sure they're going to want it the first way, but it's all the same, right? You're just multiplying 3 things together. All right, we'll talk about these super quickly. Whenever you're multiplying square roots, if they're both square roots, you can just multiply the stuff together. Notice there's no addition or subtraction signs underneath the radical, right? Okay, there's no addition and subtraction signs. It makes it fairly easy. So we have square root of 6x times square root of 3x squared. I can go ahead and call that square root of 18x cubed. And the square root of 18 is 9 times 2. So we can pull the 9 out as a 3. We got that 2 still hanging out inside. Yep, and then we got 1x left on the inside. Is that okay? And then the next one's going to work the exact same way. You guys are just going to stick it all together and reduce it. Square roots have an invisible 2 in there, and it's saying find pairs of stuff. So that's the reason this works. So if I give you some long whatever, so pretend I'd multiplied all that out and gotten whatever big number that is. What I'm really doing is I'm just looking for pairs and pulling them out. So there's a pair of 4s, comes out once. I see a pair of 12s, comes out once. Pair of 3s, comes out once. 2 has no friends. 2 stays in. Oh, it'll want you to multiply them out. Yeah, I'm just trying to show you guys to pull out the pairs. But very good question. No, very good question. And as far as descending, so that's typically going to be like with your exponents, where you want your exponents in descending order. So highest one first and go all the way down with the number with no exponent, or sorry, with no variable being at the end. So yeah, very good call, because I think it actually probably will ding you. And if it doesn't in the beginning, it will later. All right, more radicals. So to combine radicals that you're adding or subtracting, the radicals have to match. So think of the square root, whatever it is. So that radical is kind of like a variable. If it matches, you can put them together if you're adding or subtracting. If they don't match, you can't. But sometimes it's tricky, because square root of 8 can be rewritten as what? Yeah, so it's 4 times 2. We pull the 4 out as a, So 2 root 2 plus 3 root 2. What this is saying is I have 2 root 2's and I have 3 more root 2's. It's no different than I have 2 apples and I have 3 apples. How many do I have total? Yeah. So 5 root 2. So like I said, they can be a little bit tricky. This next one, so square root of 63. 63 is 9 times 7. So 9 comes out as a, So 3, the 7 was just by himself. X stays in there because he doesn't have a friend. Minus 27. 4 times 7. 4 comes out as a, yep. So now we have matching radicals. So now we've got the 3 square root of 7x minus 2 square root of 7x, which is going to leave us with, right, it's going to leave us with 1 square root of 7x that we're just going to write square root 7x. Same idea as like whenever we have like 1x, we just write x. Same's true here. Instead of writing 1 square root of 7x, we're just going to write square root of 7x. This I'm going to mention only briefly because your calculator will do it, and we still have about half the stuff to get through and 20-ish minutes to do it. But you don't want radicals in a denominator. Technically, it's not proper. Your calculator will automatically go ahead and rationalize everything for you, what your calculator is doing. So we don't want a square root of 5 on bottom. So if you just multiply by root 5, it'll go away. You can't just do it on the bottom. Got to do it on top. So now root 5 times root 5 gives us what? Yeah, a whole 5, right? So square root of 5 times square root of 5 gives us 5. If that doesn't click for you, that's the same as square root of 5 times 5, or square root of 25, which will give us 5. And on top's going to be what? Yeah, square root of 10. And then you're just done. There's nothing else you can do. We're not going to bother with the next one, but same idea. We'll mention this very quickly and briefly. So conjugate, if you have something that's two terms, so this is 3 plus square root of 11. If you want to, we don't want a radical on bottom. We can't just multiply by square root of 11 because we end up with 3 square root of 11. But do you guys remember the difference of squares? Remember you guys were factoring? So if you had the same thing here. Yeah. You guys remember that? Okay. Same idea here. We don't want a middle term, so we're going to multiply top and bottom by 3 minus square root of 11 over 3 minus square root of 11. And then you're actually, you're technically foiling here. You guys remember FOIL from like forever ago or this summer, depending. One of the two. On bottom, we end up with 3 times 3, which gives us the 9. And then 3 times negative 11 is going to be negative 3 root 11. And then 3 times positive square root of 11 is going to give us the positive 3 root 11. Those canceled. And then we've got the square root of 11 times negative square root of 11. So negative 11 on the bottom. On the top, we're going to distribute. So 13 times 3 is going to give us 39. And then 13 times negative square root of 11 is going to be minus 13 square root of 11. So all that's just going to be 39 minus 13 square root of 11 all over 2. That all right? Okay. Yes, thank you. Good call. Negative 2. I probably didn't mention it earlier. I will mess up. Do tell me. All right, more radical stuff. This is actually fairly important. This is taking it from a radical to a rational exponent or a fraction exponent. We said that square root has an invisible 2. So we just have, let's see, we'll put an x. We'll just put an x. If I want to rewrite this, so again, that's supposed to be a 2 there. If I want to rewrite this without the radical symbol and I want to use an exponent, it's going to be x to the 1/2 power. So whatever's in the little, whatever's in the crook part of the radical, put in the bottom of your exponent. So we have the 5th root of x. It'll be x to the, yeah. All right, now let's make it a little bit more fun. Let's give the x a exponent. Let's see, we'll do the 7th root of x to the 10th. Okay, I'm hearing you guys tell me the steps, so I'm going with it. Yeah, you guys agree that's still the same? All right, well, we can keep going. And because this is a power to a power, we multiply. So just x to the 10/7. Yeah? Okay. Let's do one more. Let's see. Let's do 10th root of x to the 4th. It's going to give you what? What number goes on top, 10 or 4? No, I've tricked you. So x to the 4/10. Because remember, whatever's in the radical goes on the bottom. I was going to say, and then that 4/10, we need to reduce it, just like we would any other fraction. So we're going to have x to the 2/5. Sorry, those equal signs keep being horrible. We'll do this guy really quickly, like really quickly. So the first thing we can do is put it all together because it's both fourth root and fourth root. So we got fourth root of 162x to the fifth over 2x. We can reduce stuff here, right? So fourth root of 81. And then this one actually reduces all the way. What do you fourth to get 81? Any ideas? 3, yeah. Because 3 times 3 is 9. 3 times 3 is 9. So there's the 4 of them. If you multiply those together, you get your 81. And then what about this x to the fourth? Yeah, it's just going to be x. Because it's x to the 4 over 4 if we were to take it to rational exponents or think about it that way. And because it was a even power, I should technically put absolute value. All right, so there's your official definition, which I already let you have fun with. So we're going to skip it and see if we can get through 3 sections in 20 minutes. Polynomial. Basically, it's just a whole lot of terms. Or it can be a whole lot of terms, I should say it that way. So a polynomial in x just means that x is your variable. You're going to put them in descending order. Whenever it asks for the degree of a polynomial in x, it's just saying what's the highest exponent attached to x. Whenever you're adding and subtracting polynomials, adding is super easy. So all you're going to do is combine like terms. So negative 7x cubed and 19x cubed is going to end up giving us, it'll be positive, 12x cubed. And then we have the 6x squared, negative 11x squared. Yep, minus 5x squared. Negative 11x plus 7x. Yep, minus 4x. Plus 13 minus 17. Yeah. So the adding part's super easy. The subtracting, we got to do one extra step. Subtraction is like a negative 1 being on the outside and being distributed. So if you want to get rid of these parentheses, you got to distribute. Yeah. So the first part I can just rewrite because there's nothing in front, so I can just drop the parentheses. So we have 8x squared plus 7x minus 5, and then I'm going to distribute this guy to get rid of the parentheses. So, negative 3x squared plus 4x. And then what we're kind of doing is you stop, right? We're going to think about the next part separately. Whenever you distribute something that's up against parentheses, you stop at the end of those parentheses. So that negative just stopped. Now we're looking at the rest of this. Now it happens to be that we have another negative we're going to distribute. So whenever we take this negative through, yeah, perfect. We can combine like terms at this point, so I'm going to use another color. So we got 8x squared minus 3x squared. Oh, I'm not even starting with the highest one, am I? We got to do this guy first. We're going to put it in descending order. We have a cubed, so that guy gets to go first. He has no friends, so it's just going to be 6x cubed. Okay, now let's put the squareds together. So the 8x squared minus 3x squared gives us, because it was a positive 8 and a negative 3, yeah? Oh, because I forgot to write the squared. Thank you. All right, let's fix this. So we're going to come back to that in just a second. What I forgot was that squared. Thank you, thank you, thank you. Yeah, big difference, right? Don't do this on your homework. Okay, so now 8x squared minus 3x squared plus, oh, and then I put, oh, no, I did. So plus 5x squared is going to give us what? There we go. Thank you. All right, now let's just do our x's. So we've got 7x, 4x, and then just the stuff that's left. The minus 5 minus 3. Yep. Is that okay? All right, and I put an example down here from your book that I thought was super because it's explaining between addition versus multiplication. That was addition of the 5x to the fourth plus 6x to the fourth. You're adding how many x to the fourths you have. You're basically just counting how many x to the fourths you have. Whenever you're multiplying them, you're going to be multiplying the numbers together and then also multiplying the variable and their exponents together. With addition, 5x to the fourth plus 3x squared, you can't do anything. They're not like terms, so you can't put them together. The biggest mistake is people trying to add exponents whenever you're just adding like terms, or you're supposed to be adding like terms. You guys like to make things cute and neat and little, and so you just keep making up rules till you get it small enough you're happy with it. So try not to do that if possible. Okay, so I mentioned this at one point whenever we were talking about the difference of squares. And we actually sort of wrote it down. But the reason we care about the products and sum and differences of two terms really is just for the multiplying. We would use FOIL up here to get to the a squared minus b squared, and the middle terms would cancel out. This is just the shortcut. FOIL works. FOIL is just multiplying. It's just distributing. So we're taking, I'm going to skip the one that takes longer and do number 2. So number 2 really is 5x squared minus 3 times 5x squared minus 3. If there is a plus or a minus sign in those parentheses and then another exponent, write it out. Okay, you can't distribute because that's subtraction in the parentheses. So now we're going to FOIL. So 5x squared times 5x squared gives us what? To the fourth, yep. And then let's do the 5x squared times a negative 3. Negative 15x squared. Okay, now let's do, let's switch. The negative 3 times 5x squared. Negative 15x squared. And then our last one, we're going to do the negative 3 times the negative 3. Positive 9. We need to combine like terms anytime we can, and this time we can. So the 25x to the fourth stays. There we go. Negative 30x squared. Thank you. And then just the plus 9, right? That one okay? Here we would reduce and then multiply. I'm not going to do the multiplying part, but we will do the reducing part. I know this is a lot bigger than just x, but it's the exact same base. 2x minus 7 is the base with exponent of 5. 2x minus 7 is the base with exponent of 3. Exactly, you can just subtract the exponents. So we'd end up with 2x minus 7 to what power? Yeah. And then you would write it out and go ahead and FOIL or go ahead and multiply. Again, on the notes, I've included all these nice little fun things. But really, these are just, they're trying to be shortcuts, but as long as you guys know how to multiply and how to FOIL, how to distribute, you're fine. So to me, it's some of it's super useful and some of it just takes up brain space. But it's there, so you can make the decision as to which it is. All right, factoring. So this is super huge and important, and we're going to try to cover it in like 5 minutes. So whenever you're factoring, which will not go away, you always want to see there's a common factor amongst all the terms. So you always look and see there is something in common and pull it out first. Always do that first when you're factoring. Some of the time, what you have to do that before you can continue to factor. The rest of the time, you just won't have it fully factored unless you happen to recognize and pull a number out later. Anyway, We'll talk about that more. But first, let's factor by grouping. Factoring by grouping is whenever you look for something. Well, this is technically not factoring by grouping. Number one is just factoring out the greatest common factor. What's the greatest common factor between x squared times 2x plus 5 plus 17 times 2x plus 5? 2x plus 5. So this one's technically just pulling out the common factor. Yeah, exactly. You're left with that x squared plus 17. And then these are done. They won't factor any further, but do always look just to make sure. Factoring by grouping is whenever you have 4 terms. You're going to look at them 2 at a time. X cubed minus x squared. What's in common with those two things? X squared will come out, leaves me with x minus. Perfect. Keep this sign. So minus, we're going to be pulling out a negative. But between 5x and 5, what's in common? Yep, so we're pulling out negative 5. Negative 5 times what gives you negative 5x? And then negative 5 times a negative 1 will give us that positive 5 up there. We're going to pull out the matching parentheses. So x minus 1 is the matching parentheses. And then we have x squared minus 5 left. Nothing will factor any further than this. So we're done, but we would still want to look and make sure. Okay, so factoring whenever your leading coefficient is 1, meaning you have an x squared plus bx plus c. So x squared plus, well here, let's do number 3. X squared minus 14x plus 45. Okay, well good. All right, so evidently mode 5.3 on your Casios will help you get this. It gives you, does it give you the actual factors or does it give you the answers? Okay, so what it's doing is actually giving you the solutions if this was set to 0. So we're looking, but the old school way without the mode 5.3. Is it 5.3 or 3.5? 5.3? 5.3. Yes. Is to find two numbers that multiply to a positive 45, which means the same signs, and adds to a negative 14, which means they're both negative. And then 9 and 5 will work. Same idea for the second one, but again, we're going to skip it. If you have the, so 9x squared minus 9x plus 2, this is different because we have something that's not a 1 in front. I assume your calculator mostly does this too, but I'm gonna force us to go through it once. So the AC method is taking whatever is in front of the x squared, multiplying it times the whole number. So 9 times 2 is going to give us 18, and then we need factors that multiply to 18 but add to a negative 9. Because you're adding to a negative and multiplying to a positive, I know that the signs will be the same, because they multiply to a positive, and they'll both be negative because it went to a negative 9 whenever we added. So you can do your, so 1 and 18, 2 and 9, 3 and 6 works great, right? Both negative. So I'm going to rewrite, I'm going to keep my 9x squared, but instead of this minus 9x, I'm going to put minus 6x minus 3x. So I'm just rewriting that middle term, and then plus 2. Just distinguishing. So now I'm going to factor by grouping. I'm going to look at these two. I'm going to look at these two. 9x squared minus 6x has what in common? What else? 3x. And I'm left with minus 2. Nope, hey, you're doing great. All right, and we got to pull out a negative because we're going to always keep this sign. What's in common with 3x and 2? Nothing. So I'm going to put a 1 there so I don't forget it. And then 3x minus 2. So now we have matching 3x minus 2's. And then stuff left. Exactly. Just the 3x minus 1. That okay? So whenever we're factoring the difference of squares, go ahead and set it up. Whatever you square to get this first one, you put in the front of both. So what do you square to get 81x to the fourth? 9x squared. What do you square to get 1? 1. And then opposite signs. Factoring cubes. So cubes, the way I remember these. Let me back up. So I need to figure out what I square to get each of these. I'm going to do the harder one first. Well, I'm going to do the harder one, period. What do you square, what do you cube to get 8x cubed? 2 what? 2x. So this is 2x cubed. What do you cube to get 125? 5. All right, this is completely not the mathematically correct way to say it, but this is how I always remember it. First thing I do is I put my signs in, and it's going to be a short set, a long set. It is always the same sign, an opposite sign, and a plus sign. Same, opposite, plus. So I got my signs in. I know I at least got that right. Now, as far as filling in my sets of parentheses, and I'm going to call this guy the first. I'm going to call this guy the second. So I need one of the first. So whenever I say one of the first, I mean 2x. Then one of the second. 2 of the first. Whenever I say 2 of the first, I mean squared. 1 of each. So I got a 2x and a 5. And then 2 of the second. And I'm going to rewrite it. So I'm going to have 2x plus 5 times, what's 2x squared? Yes, 4x squared. Then minus 10x plus, perfect. So same sign, opposite sign, plus sign. One of the first, one of the second. No. So it's going to be plus minus plus. But these follow the same pattern, and truly, you just got to do enough to memorize them. Okay, let's see if we can do an entire section in a minute. Yeah, a minute and a half. Thanks, makes me feel better. So rational expressions, polynomials on the top and or the bottom of a fraction. That's all it means. So rational, fancy word for fraction. We cannot have a 0 on the bottom. We're never going to divide by 0. So it'll say, figure out what numbers are not in the domain. It means take the bottom, set equal to 0, and solve. So x minus 3 is not going to be 0, which means x is not going to be 3. Okay? Whenever we are dividing or simplifying, you're going to want to factor everything and scratch what matches. So on top, we're going to factor. We have 3x minus 3 over x squared minus 6x plus 9, x minus 3, x minus 3. And the x minus 3's match? Yeah. And that one's done. You guys are probably going to need to do the rest of this, or at least review the rest of these at your house or computer lab or whatever. But the multiplication and division, multiplication, you're going to factor first, reduce. The division, keep, change, flip. Keep the first guy the same, change to multiply, and I just went to the wrong page, and then flip the second fraction, just like with dividing fractions.